Welcome to Mattress Talk TV. I'm your host Phil Dameron, and today we're in our series on foam, and we're going to be talking about polyurethane foams. Now this is a piece of polyurethane foam here. They came out in the late 50s, early 60s. They kind of cut into the sellability of latex. Latex sales went way down, but polyurethane didn't quite make it as a mattress. It's been used, but it never gained a lot of traction. They use it a lot in layers. It makes a great layer. The problem was it wasn't quite as supportive enough as it could have been. So you see it in cushionings, in pillow tops, in quilting. You'll see it in base layers on other types of beds. But remember, viscoelastic foam is also a polyurethane, just a different style. So let's take a look at polyurethane. There's a couple things that make polyurethane. One is the density of the foam, and one is called an ILD number. So let's come in a little bit closer and we'll talk about that a bit. One of the things we need to talk about is foam density. Now a foam cell is generally kind of roundish, not perfectly like this, and what we're going to do is we're going to take this ping pong ball, put them in this container here. You can see how many we have. Over here we're going to take a much smaller sphere, a marble, and you can see how we have those packed in here. This would be a high density foam. There's a lot more foam cells in it. They're more tightly packed. This is a lighter weight foam here. Foam can go anywhere from, say, a 1 pound foam on up to about 7 pounds. What that means is 1 cubic foot of a lightweight foam could be 1 pound. A higher density foam that's maybe a 3 pound foam, that same cubic foot would be 3 pounds. So as you can see here, we can pack a lot more in. When you have fewer cells, a lot of times the foam tends to be a little bit stiffer because you have to manufacture it so it's a little bit more rigid so it just doesn't totally collapse on you, because there's a lot more air in here. The other problem you have, you get a lot of breathability and you dry the foam cells out, and when those cells pop, then they compress and you have potholes. When you go into a high density foam, there's much more foam cells and there's less air circulating through it, and they tend to use different chemicals that kind of seal the foam cell a little bit better so it doesn't dry out as quickly. So, you know, here we'd be looking at, say, a 1 pound foam. They make 2 pounds, 1.8, all kinds of different densities. Most foam manufacturers, you can go to them and ask them for a specific density level and then a firmness level, and so they can formulate that and come out with a product that would suit your needs. So now let's talk about deflection. Now let's talk about the firmness of foam. All foams will have what's called an ILD number. It's an impression load deflection number, and all that means is you'll take a piece of foam, say 4 inches thick, they put a plate on top and they push weight on the foam, and they want to deflect it 25%. They want to compress it 25%. How much weight does it take? There's all different weights. You know, a 15 pound or 18 pound, 20 pound is going to be fairly soft. When you start getting up to a 30 pound, a 34, 35 pound, that's kind of a medium. Once you start getting into the 40s, you're getting into a very firm foam. So you combine those two numbers. A 1.5 pound foam, it would be a 1530. That'd be a 1.5 pound foam, a 30 pound ILD. You could go down to a very lightweight foam, a 1030. That would be a 1.0 pound foam with a 30 pound compression. As you get denser foams, if you get to a 2030 as opposed to a 1030, the density level does change the feel a little bit, and so you do get a little different feel to it, but firmness wise it's going to be very, very close. Now viscoelastic foams, the memory foams, are also a polyurethane foam, so the density numbers stay the same. When you get into memory foam, you see a lot of 5.3 pound foams, 6 pounds, 7 pounds. You can get lower. The lightest weight that you can go is about 3.4 to 3.5 pounds with the viscoelastic structure. What happens there is you lose a lot of structural integrity. It's just not as durable. So you really want to keep it above 4 pounds if you can keep it there. So let me grab some optical aids, and let me show you a little different on cell structure. Okay, we have some of our high-tech visual aids here to help us talk about foam. We're talking about polyurethane foam and viscoelastic foam. Regular polyurethane foam is what's called a closed cell foam. Closed cell foam looks like a little balloon. It's a solid sphere. And when you put weight on this, you'll see how the balloon flexes and things. Now your density changes the number of actual balloons. So a higher density foam has more balloons. So if a balloon pops, you still have lots of other balloons to hold you up. The ILD number, the firmness number, what they can do is change the firmness of the balloon by changing air pressure or the shell to make it stiffer or softer. But this is a closed cell foam. Now your viscoelastic foams are what's called an open cell foam. And we've got this here. An open cell foam is not like a balloon. It has holes all through it. Now not as many as this, but this is the best I could find as far as visual aids go. A lot of companies call them windows. The thing with viscoelastic foam is it's very breathable because the air can circulate through it. But on the balloon, when you put weight and it squishes out, with a viscoelastic foam, this cell can actually collapse. So if you're sleeping on your side, the foam actually collapses around your shoulder. And if you can envision a lot of these on top of each other, collapse, 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 until it equalizes your pressure points. And the cells adjust to your weight. So not all of them will collapse. Now when you get out of bed, the foam comes back into shape. So it's just a different cell structure than a regular polyurethane. This is much, much more breathable. Now, it also helps reduce pressure points over this one because this one doesn't adjust to body weight as much as a viscoelastic shell. One other thing that does happen when you're constructing viscoelastic foam, the cell structure does become temperature sensitive. It's the polymers and stuff they use in the foam. When this foam gets cold, this does not move as fast and it feels firmer. Once you crawl into bed, if it's very cold and your body temperature warms it up, then it becomes faster acting. So you just have to know that with some memory foams, it's going to be a little bit slower moving and compressing until it warms up to your body temperature, but then it's going to support you just right. So that explains a little bit about polyurethane foams and viscoelastic foams, and kind of wraps up the series on foam. If you have any questions, drop us an email, let us know. We'll try to answer those to you. We hope that this information is useful to you. When you go out shopping, now you know about densities of foam and how they change, and the firmness, the ILD number of the foam. You start talking numbers like that, the salesperson will know that you know what you're talking about, or possibly you're a competitor trying to shop them. Anyway, we hope you can use this information to help you get a better night's sleep. Thanks for watching Mattress Talk TV.